Good afternoon, everyone. My name is Krishna Prasad Mainali. My student ID is C7575 192. My research focus on intelligent network routing using machine learning for optimized data transmission. This work was conducted as part of my MSc IT uh, under the supervision Dr. Roshan Chitrakar. The motive of for this research comes from the growing demands of modern network, especially with the rise of IoT, cloud computing, and real-time application. Even satellite communication. Traditionally, routing protocol like OSPF and or ECMP are increasing limited as they cannot adapt effectively to rapid traffic changes and diverse service needs. This is where machine learning, particularly reinforcement learning, can play transformative role. The The aim of dissertation is intelligent network routing based on the machine learning techniques for optimized data delivery, especially focusing on critical discussion related techniques for reinforcement learning, deep reinforcement learning, and hybrid ML SDN approach. The study will assess how this ML method can solve challenges uh, can solve challenges regarding routing efficiency, latency improvement, scalability, and robustness. In dynamic networks such as SDN, satellite network, and heterogeneous IoT. The problem statement of my dissertation, uh, my topic, with the exponential grow in data traffic from 5G, 6G, IoT, and cloud service. Traditional routing methods struggling with efficiency, uh, efficiency, scalability, and robustness. They are static and naturally, and cannot handle dynamic environment as well. Machine learning, and especially reinforcement learning and deep learning, has the ability to learn and adapt in real time, making it too promising candidate for intelligent routing. However, uh, challenges, however, challenges remain, such as the high computational cost, reliance, and simulation, reward design issues, limited real world deployment. Where my research especially address this gap by evaluating, uh, evaluating evaluating my research gap, evaluating ML based routing framework in dynamic network condition, aiming to identify their strength, weakness, and opportunity for future development. The main aim and objective of my dissertation is uh, analyze and evaluate how ML techniques, especially RL and hybrid approach, can use for optimized network routing. The objectives of my dissertation is focus on RL and hybrid approach, study methodology and algorithm for prior search, evaluate scalability, flexibility, robustness in dynamic setting like SDN, IoT, and satellite network. Compare supervised learning and reinforcement learning approaching through experiment. Identify uh, identify identify performance trade-off and open issue in ML based routing. The methodology of my this is network topology, where 9 router are uh, data transmission one to another router. The methodology of my dissertation of my topics, uh, which is also shown as the block diagram figure on poster. Here is my methodology figure block diagram. Uh, we generate the synthetic network topology using the random graph model. Each link as assigned based on the delay and capacity to simulated real conduction. We dynamically pre-tutored delay and bandwidth mimicking conjunction and failure. First, we compute the multiple candidate path between the source to destination. We are extend extract feature and average delay, residual bandwidth and hop count. For supervised learning, we build the label dataset where the low latency path and mark as optimal. This dataset is used to train and random forest uh, classifier. Finally, performance was evaluated using latency, throughput, packet delivery ratio, and classify accuracy. Additional analysis included confusion matrix. Here is my confusion matrix. Uh, Confusion matrix, feature importance and static validation with t-test and confidence interval. Here is the result and finding. Here is evaluation two approaches: random forest mean latency 2.741 ms, DQN mean latency 2.896 ms, where random forest is best latency. Here is a learning curve random forest. Okay, the result and finding. Uh, the network topology the network topology illustrate how dynamic state were simulated and showing the nodes and varying link delay. The random forest curve demonstrate is strong predictive accuracy over 90% test dataset. Confusion matrix and F1 score confirm its reliability. Importance feature, important analysis, important analysis revolve that average delay was the most influential factor in routing decision. Though random forest model significantly outperform it, achieving the lower mean latency and high packet delivery. The conclusion of my dissertation is so that machine learning method, particularly reinforcement learning most method, particularly reinforcement learning, can greatly enhance network routing decision compared to traditional method. The random forest approach work very well under known condition, providing strong predictive accuracy. Reinforcement learning, however, proves superior in highly dynamic environment, constantly reducing latency and improving packet delivery. Uh, Hybrid approach came random forest, which combines supervised and reinforcement learning, represent the best path forward. Although my work is limited by simulated environment, it is establish a strong foundation for real world testing and future research. especially in 6G, IoT, and satellite. Here is the reference, and I would like to show my, this is prototype where is Python code shows, here is show the result, 2000 data manipulate, and here is the comparison between uh, random forest and DQN. Random forest give the best result on comparison between two. Okay, thank you. My best my my approach is optimize the uh, data transmission using machine learning. Thank you everyone.